Today we'll be doing the integral from 0 to 1 of the square root of x times the natural log of 1 plus the square root of 1 minus x divided by x dx. And to start, we will rewrite this integral. So we can rewrite this as the integral from 0 to 1 square root of x, the natural log of 1 plus the square root of 1 minus x divided by x. But now I'm going to multiply both the numerator and denominator by a factor of square root of x. So our integral becomes the integral from 0 to 1 of x log of 1 plus the square root of 1 minus x divided by x times the square root of x dx. And the x's divide to 1, so we're left with the integral from 0 to 1, the natural log of 1 plus the square root of 1 minus x divided by the square root of x dx. And now from here we could use integration by parts. So now we're going to let u equal the natural log of 1 plus the square root of 1 minus x, which means that du equals 1 over 1 plus the square root of 1 minus x. And then the derivative with respect to x of 1 plus the square root of 1 minus x. So that means that du is 1 over 1 plus the square root of 1 minus x times 1 over 2 square root of 1 minus x, but by the chain rule will be the derivative with respect to x of 1 minus x. So that means that du equals 1 over 2 square root of 1 minus x times 1 plus the square root of 1 minus x, and then times a negative 1. And then dv will be 1 over the square root of x, which means that v equals 2 times the square root of x. So using all this information, we have that our integral will be u times v, which is 2 square root of x, natural log of 1 plus the square root 1 minus x from 0 to 1, minus the integral from 0 to 1 of v du. So we have a 2 square root of x times negative 1 divided by 2 square root of 1 minus x times 1 plus the square root of 1 minus x dx. And as x approaches 0 and x approaches 1, this limit will tend towards 0. And as you can see, this negative and negative make a positive, and this 2 and this 2 divide to 1. So we're left with our integral is the integral from 0 to 1 of the square root of x divided by the square root of 1 minus x times 1 plus the square root of 1 minus x dx. And from here we can make a substitution. So we'll let y equal the square root of 1 minus x, which means that y squared equals 1 minus x, which means that 1 minus y squared equals x. And that means that dx equals negative 2 y dy, and the bounds of integration, y1 will be 1 and y2 will be 0. So our integral is now the integral from 1 to 0 of the square root of x. But if we solve this equation, we have that the square root of x equals the square root of 1 minus y squared. So square root of 1 minus y squared, and then we'll have a y times 1 plus y, and dx is times negative 2y dy. But as you can see, this y cancels, and we can use this negative to flip the bounds of integration. So we have I is the integral from 0 to 1 of 2 square root 1 minus y squared divided by 1 plus y dy, which this means that I is twice the integral from 0 to 1, the square root of 1 minus y squared divided by 1 plus y dy. And then from here, we could use a substitution. So we'll let y equal the sine of theta, which means that dy is cosine theta d theta. And that means that theta is the arc sine of y, which means that theta 1 is 0, and theta 2 is arc sine of 1, which is pi over 2. But this also means that the square root of 1 minus y squared will be cosine of theta. So our integral transforms into twice the integral from 0 to pi over 2 of cosine theta divided by 1 plus the sine of theta, and dy is cosine theta d theta, which means this is twice the integral from 0 to pi over 2 cosine squared theta divided by 1 plus the sine of theta d theta. And we know that the cosine squared of theta is 1 minus the sine squared theta. So this is twice the integral from 0 to pi over 2, 1 minus the sine squared theta divided by 1 plus the sine of theta d theta. But we know we could factor 1 minus sine squared. 1 minus sine squared is the same thing as 1 minus sine theta times 1 plus sine theta. So using this information, we have this is equal to twice the integral from 0 to pi over 2 of 1 minus the sine of theta times 1 plus the sine of theta divided by 1 plus the sine of theta d theta. But we see some nice cancellation here. So this is none other than twice the integral from 0 to pi over 2 of 1 minus the sine of theta d theta, which is a really easy integral now. So we have twice theta minus negative cosine theta, evaluate from 0 to pi over 2. This is equal to twice theta plus cosine theta from 0 to pi over 2. Now we have to evaluate the endpoints now. This is equal to twice pi over 2 plus cosine of pi over 2 and minus 0 plus the cosine of 0. So our integral is twice pi over 2. Cosine of pi over 2 is 0, minus 0, and then minus the cosine of 0. So this goes away, and we have I is twice pi over 2. Cosine of 0 is 1, so minus 1. So this means that our integral is pi minus 2. So this is the final result.